Alright, this is a video to kind of help. Um, I made the adjustment from using just the graphing calculator TI-8384 to using EasyCalculation.com. So this video here is basically to assist those folks using Easy Calculation to complete the same assignment. So this is question number 13 on section 10.1 scatter plots and correlation. The particular website that we're going to start off on this page to kind of see the layout here is easycalculation.com graphs scatterplot, which is listed if you look at the assignment. If you're using, so if your directions for those students using easy calculation, right here it says draw a scatter plot for the variables, and it gives you the link to the website right there, so you can just have that handy and just open the website right up. Okay. All right. So with that said, what we had is you're gonna do a scatter plot. So the way this website works is you go to the website and it asks you for the information. So this is a screenshot. I'll show you what the live site looks like in just a second. And basically you can name the scatter plot. You can give the x-axis a name, the y-axis a name. Those are just your x variables and your y variables. You enter all your x's all at one time, and you don't put any spaces. You just put a comma between all the x's. And then the y value is the same way. You enter all the y's, no spaces, and there should be a total of 9 numbers in each one. Then you go ahead and press generate scatter plot. It shows you your x and y list just like you have on page on section 10.1 suggested homework number 13, and then it kicks out the scatter plot for you. And so what this is doing is that we're trying to work on this whole idea of a line of best fit, which will come up at some point. And so, like what's happening right here is that we're just drawing this line here, this best fit line, this line that kind of best fits the data. So, if you can kind of imagine, drawing that line through there. And that line is calculated, using these different data values. All right, so next part of the question was now compute the correlation coefficient. So they have a correlation coefficient calculator, and so same thing, here's a screenshot. This time you actually enter your x values in a list, your y values in a list. You hit calculate. To add more, you hit add more right there. So let me go ahead and go to the website and show you what it looks like. So here's what it looks like when you're putting it in. So if there were more numbers, every time I get to the end right there, I'd click add more. It gives me one more spot to keep on adding. Once I have everything I want, I go ahead and say calculate, and see there's a mistake there, so I'll hit fewer, calculate, and it gives me my number of numbers and my correlation coefficient. So it's super easy to use. Once again, the website is linked onto the suggested homework assignment. Okay, so once you do that, now we have our correlation coefficient. So let's go ahead and take that correlation coefficient, that relationship. The correlation coefficient is a number that shows how strong the relationship is, the x and y relationships are to each other. So let's go back to, I'm a visual learner, so let's go back to this visual picture here. The correlation coefficient is 0.8. The strongest correlation coefficient that you can have is 1 or negative 1. Positive 1 just means that the line is moving in a positive direction. If it was a negative correlation coefficient, then that means that the line would just be moving in a negative, excuse me, sorry about that, would be moving in a negative distance or negative relationship. So we're in a positive direction. We have a positive correlation coefficient of 0.8. What that means is how strong is that relationship to the relationship between x and y to this particular line? How close is it to a perfect line? So a correlation coefficient of positive 1 would be where all the points are like right on the line. So if I had a correlation coefficient of 1, it would be like perfect relationship. The closer I get to 0, the less the relationship. Okay, so now let's state the hypothesis. So in this case right here, we go with the standard hypothesis. So we're going to say our null hypothesis, and here I am right here. Let me highlight so you can kind of see what I'm talking. So here I am right here, and it says, the null hypothesis means that there's no correlation between x and y. That's if we say the correlation coefficient is 0. So that's what I was just telling you about, was I was saying that if your correlation coefficient was 1, that would be perfect. If it was negative 1, that would be perfect. But the closer you get to 0, the less the relationship. So our null hypothesis is going to be that our relationship is 0. Our alternative hypothesis will be not equal to 0. So that means somewhere else besides at 0. So although hypothesis tests can be one-tailed, most hypothesis tests involve the correlation coefficient are two-tailed. Recall that, and I forget the name of it, that Greek letter P represents the population correlation coefficient. Also, if there is no linear relationship, the value of the correlation coefficient will be 0. Hence, all are null and all alternative hypothesis. So that's our statement of right there. So our null and alternative are right there. Okay, next part was test of significance. So the test of significance, we're going to use table I. Table I is located on page 793. So let me go ahead and type that on there for you so you can see that. Sorry about that. Oh my goodness. 793. Okay, so 793 in the appendices of your textbook, you'll find table I, and I'll show that to you in just a minute. So from our previous situation here, we had our total numbers of 9, our correlation of 0.8. So we roll over to our table I, and here it is. And what we're looking at here is that we want to take this critical value, this value, our degrees of freedom, excuse me. So remember, our degrees of freedom is going to be equal to our d dot f is going to be equal to n minus 2. So in our case here, our d dot f is going to be equal to 9 minus 2, which is equal to 7. So we come over and we look at a degrees of freedom of 7. So that means that my critical value for this problem is going to be 0.666. Okay, so my critical value is 0.666. Okay, and I'm going to go ahead and type it in both spots. Actually, let's go ahead and we'll make that one negative 0.666 because it's on the negative side. And then we'll come over here and we'll make one, and this one over here will be 0.666. I'm having a heck of a time with my keyboard today. Okay, so those are my two critical values. That means that on this side here, because that's the negative side of my distribution, that's the negative standard deviations on my distribution, that critical value is 0.666. This side is 0.888. Our correlation was, I'm sorry, 0.666. Our correlation is 0.880. So that means that our correlation is going to be located out here in this region, somewhere over, let's say maybe about right there. Okay, it doesn't really matter, but the point is that our correlation coefficient is in the critical region. Okay, so if we go back to our question here, test the significance of at that level of 0.05 level using table I. So we've tested it, we found out that we're in the critical region. So since we're in the critical region, what we can say is, we can make our final conclusion, we give a brief explanation. There is sufficient evidence to conclude that a significant relationship exists between the number of releases and the gross receipts. So what does that mean? As far as what we're going to do, basically that means that we would reject our null hypothesis. We would get rid of that null hypothesis because obviously we've shown, if we go back to our original statement here, obviously we've shown that our null hypothesis, we were equal to 0. We're not equal to 0. So we would reject that null and we would accept the alternative, or we would start to look into the alternative hypothesis. All right, so that's the procedure for section 10.1 of what you're going to do and how you're going to find your answers, and then kind of the conversation of how you're going to get through this problem. I just want to come back to this statement right here. This statement right here, this is the hardest part, given that brief explanation. So let's go back and make sure we understand. What this really comes down to is this screen right here. If we fall in that critical region, then we're going to get rid of that null hypothesis. We're going to keep the alternative. If we fall in that critical region, then we have enough evidence to conclude that there's a significant relationship, that something's going on there. So we don't want to go with our null, our original hypothesis. We want to go with an alternative hypothesis. There is some kind of relationship occurring. And that's what we're looking for. That's what we're trying to find out here is this data worth studying at this point? And the answer to this question is yes. There's some type of relationship going on here. It's a strong relationship, and that relationship is between the number of releases and the gross receipts in the millions. All right. So hopefully that helps. If not, send me an email and maybe I can try to help you out a little bit more. Thank you very much.